We are doing this question 12 from review set 8A, and we can do this question because they've given us a diagram. We've got area A and B. You can see they're right at the extremes, right at the edges of the normal distribution. So I think it's fair to assume that you've got 20%, right from, this is the first 20% of the curve here when they say 0.2, and this is the last 20% of the curve there. And given that symmetrical setup, and knowing that the mean has to be in the middle of a normal distribution, we could see that the mean would then have to be between the 20 and the 38. So it will be 29 because there's 18, a space of 18 here, and we'll be halfway along. So 20 plus 9 is 29. We can't do these questions here until we know the standard deviation. Oh, yeah, that's still part of A. Okay. So we can get to standard deviation through z-scores. Might be worth just drawing some diagrams here. We've got, we know we've been given this information, means 29, 20%. First 20% gets us up to 20. And then this number, this value was 38. If we compare it to a Z distribution, my bad. On a Z distribution, where the mean is 0, if you recall the equation for converting, but oh, excuse me. On a Z distribution, your standard deviation is 1, 2, 3. I'm going to that's not drawn well. By the time you have 3 standard deviations, you've done most of the curve, right? So let's move them over a bit. So the way you're getting there is you're taking your value like a 20 or a 38. You're working out the deviation from the mean, but you're dividing it by your standard deviation. Because on a Z distribution, it's set up so that the standard deviation is 1, 2, 3. Right? So it's all about out of how many standard deviations. That's the key to the conversion between the two distributions. Because in terms of the area under the curve and in terms of the shape, these distributions are the same. Now, I think we'll use the lower values. So let me just think about this. We've got 60% in the middle. So using the 68% rule, we'd be looking at coming just inside. And again, apologies for the terrible drawing, because it's really bad, I'm sorry. It should be more like that, but it's quite hard to draw with this pen. But hopefully that's enough for you to see what I mean. But one standard deviation would get us to 68%, right in the middle of the curve. This will be just inside these values. So I'm expecting the standard deviation to be something like 10. It has to be slightly wider than these intervals of 9, right? Because plus or minus 1 standard deviation should give me 68%, not 60%. Okay. So it's a good idea just to be estimating. I've said that on another video. If I call this in here, I'm going to call it Z1. Right? What I can do is I can figure out Z1 using inverse norm. Because I know that I've got 20% before I get to Z1. You could write something like the probability that Z is smaller than or equal to Z1 is 20% or 0.2. And in terms of working out the Z score, you're using inverse norm on your calculator. You're putting in your area, your mean, your standard deviation, and I did this earlier. So I did it up here. All right, and the value we get is minus 0.842. Minus 0.842. Okay. So now, using this information and applying it to the Z score formula, right? On our normal distribution, right? If we think about our conversion to the Z score, we'd look at deviation from the mean, 20 minus 29. On standard deviation, we don't know, we're trying to figure it out, but we know that it has to correspond to this value, 842. Okay. Has to equal that value. Now, with a bit of rearranging, standard deviation would have to be minus 9 divided by minus 0.842, and approximately, I think I did this in the calculator earlier, here. Yeah, I've got it there. I'll just copy and paste it. Might be a bit easier. So it's minus 9 divided by minus 0.842, and we get 10.7 if we're using 3 significant figures. Approximately 10.7 as our standard deviation. I might just write that down. Although I think part B of this question should be pretty easy. That was part A. So part B looked to me like it was just normal CDF. Let's have a look. What's the probability x is smaller than 35? Or what's the probability x that lies between 23 and 30? So now that we know our mean and standard deviation, we can just do normal CDF. I don't think I need to do that for you. I think it was more the first part of that question that might have been confusing. So, we've now got a curve where we know that that's 29, and we know our standard deviation was 10.7-ish. Right? So the 35, it's asking us for this area here. We could normal CDF that, right, where our lower would be minus 1 times 10 to the 99. So that's how you do this one. And to do this one, your upper and your lower, well, they're given, right? So your lower is 23, your upper is 30. Put in your mean, standard deviation, and you'll get the probability. And you can do a bit of an estimation. Right? You know that that's 60% in this diagram. Well, this value is going to have to be a fair bit smaller than that. It's in the middle. Maybe I'd be looking at about 30% or something. Okay. We might end there.